Hi guys, in this episode of Science World podcast, you will be listening about the chemical effects of current. So let's start. Myself Virendra Kumar, professor and scientist, and you are listening to me about the chemical effects of current. Pure liquids, with exception of mercury, are in general bad conductors of electricity at ordinary temperatures. However, if some metallic salt or an acid is added to a liquid, it passes some current through it. This is because the molecules of the salt in solution breaks up into ions. When an electric field is applied between the two electrodes dipped in the solution, the positively charged ions move towards the negative electrode, that is called the cathode, while the negatively charged ions, here anions, move towards the positive electrode known as anode and get discharged there. This process of decomposition of a compound by the application of an electric field is called electrolysis or chemical effect of current. The liquid containing the compound is called the electrolyte, and the device in which the electrolysis takes place is called the voltmeter or electrolytic cell. So, regarding the chemical effect of current, it is important to note that it takes place for DC and low frequency AC as at high frequencies. Due to inertia, ions cannot follow the frequency of AC. In it, electrical energy is converted into chemical energy, while in a cell, chemical energy is converted into electrical energy. In it, current inside the liquid is due to directed motion of ions and not electrons. So, in the chemical effect of the current, the electricity flows because of the movement of the ions instead of electrons. Though both the ions have equal and opposite charges and move in opposite directions, the currents due to the positive and negative ions are not equal, as anions and cations due to their different masses have different mobilities, and therefore the current associated with them are different. So total current may be given by I is equal to current due to the positive ions and plus current due to the negative ions. But never these two currents equal to each other. In it, ions get discharged at the electrodes with reduction at cathode and oxidation at anode. For example, in case of copper voltmeter with copper anode and copper sulfate electrolyte, the reduction takes place at cathode while the oxidation takes place at anode. In electrolysis case, due to the decomposition of electrolyte, substances are liberated at the electrodes which may or may not react with them. In case of soluble electrode voltmeters, cathode may be of any metal, but metal of anode and cations of electrolyte are of same element and give the name to voltmeter. Electrolytes obey Ohm's law if the electrodes are soluble. For example, copper anode with any metallic cathode in copper voltmeter is called soluble. After a number of experiments on electrolysis, Faraday in 1834 gave two famous laws known as Faraday's laws of electrolysis, that are, first law, according to it, the mass of a substance deposited or liberated at an electrode is directly proportional to the quantity of electricity, that is, charge passed through the electrolyte. Therefore, the mass liberated is directly proportional to the charge. And that means M is equal to Z into Q, where Z is called as electrochemical equivalent. The electrochemical equivalent is the characteristic of ions and is equal to the mass deposited or liberated at an electrode when 1 coulomb of charge is passed through the electrolyte. Now, second law of Faradays states that when same charge is passed through different electrolytes, the masses of substances deposited or liberated are directly proportional to their chemical equivalent. That means M1 by M2 is equal to capital E1 by capital E2 if the charges Q1 is equal to Q2. So, according to second law of electrolysis, it is important to note that as from first law, for Q1 is equal to Q2, M1 divided by M2 is equal to Z1 by Z2, and second law then becomes Z1 by Z2 is equal to E1 by E2. That means E by Z is always a constant. That means in case of electrolysis, the ratio of chemical equivalent to the electrochemical equivalent is a constant and same for all electrolytes. That is, it is independent of the nature of electrolyte. The quantity E by Z, that means ratio of chemical equivalent to electrochemical equivalent, represents the charge required to liberate or deposit 1 gram equivalent of a substance through electrolysis. This quantity of charge is called 1 Faraday, and 1 Faraday is equal to 96,500 Coulomb. Guys, if you have not subscribed the Science World podcast channel, please subscribe it and share it with your friends and colleagues so that they can also get to know about this podcasting. And I'm going to tell you that there are various applications of chemical effects of current that are first, it is used to measure the charge or current as according to Faraday's law. Charge is given by ratio of mass of the ions deposited to the electrochemical equivalent. Because of the high accuracy attainable, silver voltmeters are used to calibrate and standardize the instrument. Second, it is used to ascertain the polarity of a battery. So, with the help of the chemical effects of a current, we can determine whether the electrode is positive or negative. So, using a copper voltmeter with copper electrodes, the weight of an electrode is determined before and after passing a current from the battery for some time. If the mass of the electrode increases, then it is connected to the negative terminal of the battery. Otherwise, it is connected to the positive terminal of the battery. Thus, true polarity of the battery can be determined through the phenomenon of electrolysis. The construction of electrolytic capacitor. Since this capacitor has large capacity, therefore chemical effect of current is a very good example in the case of the construction of the electrolytic capacitors. An electrolytic capacitor consists of two aluminum electrodes dipping in a mixture of boric acid, glycerin, and ammonia water. When a current is passed, a thin film of aluminum oxide is formed on the anode due to electrolysis, which acts as dielectric. As the thickness of the oxide layer is very small, the capacitor has large capacity. Now, fourth applications of the chemical effect of current is electroplating. The process of depositing a thin and uniform layer of a metal on any conducting surface is called the electroplating. The article to be electroplated is made cathode and the metal to be deposited is made anode. A soluble salt of same metal as anode is used as electrolyte when current is passed. A thin layer of uniform thickness of the metal is deposited on the article and hence they are getting electroplated. Using this technique, Usually silver is electroplated with gold, brass with nickel, and iron with zinc. Guys, do you know that with the help of the Faraday's second law of electrolysis, we can get the atomic weight? Yes, by the application of the chemical effects of current, we can get the atomic weight of an atom. Now, the sixth application of chemical effects of current is the manufacturing of the non-metals. Non-metals like hydrogen, oxygen, and chlorine, etc., are obtained by electrolysis process. In manufacturing compounds, chemical effects of current is utilized just like compounds like NaOH, Na2CO3, KMnO4, etc. are manufactured by electrolysis process. In electro refining of metals, chemical effects of current is applied. The metals like copper, silver, gold, aluminum, and tin are refined by electrolysis process. Chemical effects of current is utilized in the electrometallurgy industry also, like metals, sodium, potassium, magnesium, and calcium, etc. are obtained by the electrolysis of fused electrolytes. These are the important things which I wanted to tell you related to the chemical effects of current and their applications. I hope this podcasting you like it, you enjoy it. Therefore, I request you to please press the like button and share this with your friends and colleagues, and please subscribe the Science World podcast YouTube channel. Thank you, friends.